to 0. Alright, let's talk about the rotation for a while. Consider forces F1 and F2 acting at points A and B of an object. Now here's an object, that is point A, and this is point B. F1 is acting at point A and force F2 is acting at point B. Now point C, there is an axis, and we are now going to look at the rotation of this object about an axis that passes through C. That's the axis of rotation. The rotation produced by F1 about the axis passing through C is counterclockwise. Is that right? The force F1 produces a counterclockwise rotation like this. So force F1 produces a counterclockwise rotation about an axis that passes through C. We call this a counterclockwise torque. The rotation produced by F2, on the other hand, about an axis that passes through C will be clockwise, will be in the direction of motion of the hands of a clock. And we call this a clockwise torque. For convenience, we take the counterclockwise torque as positive and the clockwise torque as negative. Well, we could have chosen the other way around, but we can only choose one of them, so we will follow this pattern. All counterclockwise torques are positive and all clockwise torques are negative. Now, what is the torque of F1 about an axis that passes through C? The torque of the force F1 about an axis that passes through C will be the torque arm. Now, torque arm is CA multiplied by the force F1. CA times F1, and this is a counterclockwise torque, and therefore it is positive. Similarly, the torque of F2 about an axis that passes through C will be CB, the torque arm, multiplied by the force F2. It is a clockwise torque, therefore it is negative. I hope the concept is clear because we need to use it to solve problems. Summation of tau, what is the sum of the torques of these two forces about the axis that passes through C? It will be CA times F1 minus CB times F2. This is the sum of the torques. And in order that this object may remain in rotational equilibrium, the sum of the torques must be equal to 0. Let's now talk about another simple concept. What is a couple? A couple. Well, it is very often we use a couple in our daily life. Well, by definition, a couple is constituted by two things. And of course, in this lesson, we are talking about forces. So a couple is a pair of forces. Now, the important thing about this pair is that they are equal in magnitude and oppositely directed. Equal in magnitude and oppositely directed. I showed you an example of a couple actually a little while ago. I can produce a couple on this rod. Well, I can produce a couple on this. I can apply a force upward at this end and an equal downward force at the other end. Look at that. What does a couple do? A couple produces rotation about an axis. Now, How about the steering wheel of your car? What do you do to turn the steering wheel? You see that? Now what you're doing is you use a force downward and equal and opposite force upward, so that these two forces act through different points. Now a couple is constituted by two equal and opposite parallel forces, so that their points of action are different. You see, only if their points of action are different will the couple produce rotation. If the points of applications are the same, a couple cannot produce rotation. Now, tell me, in this case that I demonstrated, one force upward and the other force downward, it produces rotation. Now, if I bring those forces closer and closer, is the rotation effect increasing or decreasing? You see, if I apply one force up and one force down very close to each other, the rotation effect is very small. And finally, if those two forces act to the same point, one force up and the other force down, will they produce any rotation on the object? No. So the rotation effect is maximum when the two forces are separated by a large distance. Now, a couple is constituted by two parallel and equal forces oppositely directed, so that their points of applications are different. Can you think of some examples of couples that we use in our everyday life? Well, any example? Any example around that we use a couple? How about opening a water faucet? When you open a faucet, you are applying one force to the directed right, then the other force will be in the opposite direction. You are using a couple to open a water faucet. How about a screwdriver? If you want to drive down a screw, look at the force I'm applying. Now I'm applying one force directed that way on this side, another force directed in the opposite direction. I'm actually applying a couple when I want to drive a screw down. So we use couples, couple of forces in our everyday life. Now let's talk about the torque of a couple. What is the torque of a couple? So a couple is formed by two equal and opposite parallel forces on an object, so that their points of actions are different. F1 and F2, here we have an object, a force F1 is acting at point A and a force F2 is acting at point B. They have equal magnitudes, means the length of the arrow are the same exactly, but they are oppositely directed. F1 equal to negative F2. Let's take a point C. We can now find the torque of these forces about an axis that passes through A. Let's take the torque of these forces about an axis that passes through A. Can you tell me, what is the torque of the force F1 that passes through what is the torque of the force F1 about an axis that passes through A? The torque of F1 about an axis that passes through A is 0 multiplied by F1. Why 0? The torque arm is 0 because the distance between the axis and the force is 0. Now, a very important concept. If a force passes through a point, the torque of that force about an axis that passes through the same point will be 0. the torque of F1 about an axis passing through A equal to 0. What is the torque of F2 about an axis that passes through A? The torque of F2 about an axis through A will be, the torque arm will be AB, and multiply that with F2. The torque arm multiplied by F2. Tell me, is this a clockwise torque or a counterclockwise torque? This is the axis of rotation where my pointer is. And see how my finger moves? F2 will rotate in the counterclockwise. So the torque produced by F2 about an axis that passes through A is a counterclockwise torque. Well, the torque of F2 about A is a counterclockwise torque. I did that one, but that is not what I wanted. Is that right? I wanted to represent this torque. The torque of F2 about A is a counterclockwise torque. That means, what is the sum of the torques about the point A? What is the sum of the torques of these two forces measured about an axis through A? The torque of F1 about A is 0. The torque of F2 about A is AB multiplied by F2. This is positive because it is counterclockwise. So the sum of the torques is 0 plus AB multiplied by F2, which is AB multiplied by F2. All right. We now take the torque of these two forces about the point B. What is the torque of F1 about the point B? The torque of F1 about the point B is the torque arm BA multiplied by the force F1, and that is a counterclockwise, isn't it? It is a counterclockwise torque. It is positive. Well, I got them the other way around. Okay, the torque of F1 about B is a counterclockwise torque. How about the torque of F2 about B? The torque of F2, now this is F2, it got covered by my arrow. This is F2, and this is the point B. What is the torque of this F2 about that point B? F2 passes through B, therefore the torque arm is 0, and that torque therefore is 0. What is the sum of the torques of these two forces about B? That will be BA times F1. But isn't BA times F1 the same as AB times F1? Because BA and AB are the same length. You see that? So the torque of these two forces, whether you take it about point A or whether you take it about the point B, it will be always equal to the torque arm, the distance between the forces, multiplied by one of the forces. Now remember, this F1 is the same as F2 in magnitude. So if you want to find the torque of a couple, what all you need to do is multiply the perpendicular distance between the forces by one of the forces, and that will be a measure of the torque of the couple. So I have defined it here. Torque of a couple is the product of one of the forces and the perpendicular distance between the forces.